And good morning, everybody. Here are your notes for the Pythagorean theorem. So let's go ahead and look at the formula for the Pythagorean theorem. So if we have a right triangle, so we have a triangle, we know that it has a right angle, 90 degrees. And if we look at side A, side B, and side C, what we can say is that the square of side A plus the square of side B will always equal the square of side C, so C squared. So algebraically it works out to be A squared plus B squared equals C squared. What this is actually describing as a geometric relationship is if you look at side A, and let's say you built a square off of side A, and you looked at the area of that square. Since the dimensions are A by A, then the area would be A squared. And if you built a square off of side B, and if this was a square, its dimensions would be B by B, length times width, so that's going to get you an area of B squared. And if you looked at side C, and again built a square off of side C that had dimensions of C by C, length times width, so that's going to be C squared. What the Pythagorean theorem is actually saying is that this area, so A squared, which is right here, so the area of square A squared, plus the area of square B squared, is always going to fit exactly into the area of square C. So this square plus this square will equal the area of the square on the hypotenuse. And the way we usually represent that as a formula is A squared plus B squared will always equal C squared. And C is going to be the hypotenuse. So let's go ahead and look at some of your notes. So looking at your note page, and I'll go ahead and fill in the blanks for you since you don't have the textbook that this came from. So the Pythagorean theorem is what we're talking about. And it says, in a right triangle, the square, so right here we're going to want to write the word square, the square of the length of the hypotenuse
Good morning at this time. Junior's last initial.
So in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. So let's go back and re-look at that picture and clean it up a little bit. So again, looking at this picture, if we have a right triangle, for any right triangle you're going to have a right angle. The two sides that form the right angle, we call those the legs. So this would be leg 1, this would be leg number 2, and this is the hypotenuse. And what this theorem is saying is if you took the square on this leg and added it to the square on this leg, it will be equal to the square that is on the hypotenuse. So that is what this passage is saying. It says in a right triangle, the square on the length of the hypotenuse is equal to the sum of the squares on the leg. Algebraically speaking, we just remember that as A squared plus B squared, where side A and side B are the legs, is equal to the hypotenuse C squared. And let's go ahead and look at the next part of the note page. So Pythagorean triples. So triples means 3, so this is going to be a set of 3 positive. So in the first blank we want to put positive. Integers. Integers are numbers like 1, 2, 3, etc. So basically non-fractions and non-decimals. So integers would be numbers like 1, 2, 3, 4, etc. They could be negative numbers, technically, are integers, but you're not going to find negative numbers for a side length of a triangle. So we're just talking about positive integers. So integers greater than 0. So it's a set of 3 positive integers, call them a, b, and c, that will satisfy the equation c squared equals a squared plus b squared. So it's 3 positive integers that will make the Pythagorean theorem true. And Pythagorean triples are kind of handy because it allows you to have a right triangle where you don't need to deal with irrational numbers and decimals and fractions. So probably the most famous Pythagorean triple is the 3, 4, 5. So notice 3 squared plus 4 squared will have to equal 5 squared. So if you work this out, you're going to get 9 plus 16 equals 25. And 9 plus 16 is 25. So that checks out. So the 3, 4, 5 is probably the most famous one. Once you have one Pythagorean triple, you can always create more Pythagorean triples just by making the triangle bigger or smaller. So for example, if you had a 3, 4, 5 and you knew that was a Pythagorean triple, so let's say we had our 3, 4, 5 Pythagorean triple. Then if we multiplied it by a scale factor of 2, then you're going to have essentially the same triangle, just twice as big. So it'd be like taking this 3, 4, 5, put it on a photocopier, make it twice as big, enlarge it. What are you going to now have if you make it twice as big? The 4 is going to get doubled and be 8. Side 3 will get doubled and be 6. And the hypotenuse will be doubled in size and be a 10. So if you multiply a Pythagorean triple by a scale factor, it's going to create another Pythagorean triple. So to go from this one to this one, you had to times 2. So the 3 gets doubled, the 4 gets doubled, so the 5 gets doubled. That's going to be 10. And if we look at the next one, how did we get the 9? So if we kind of think about how we started with a 3 and turned into a 9, looks like it tripled in size, so 9, so the 4 would also have to get tripled in size, so that's going to become 12. So our scale factor here is just making things 3 times bigger, so that becomes a 12. And then the 5 gets tripled in size, so that's going to become a 15. And you could keep going. You could make as many as you want. You could make it 4 times bigger, 5 times bigger, etc. Another common Pythagorean triple is the 5, 12, 13. And this is a different shaped triangle than the 3, 4, 5. It's a little bit longer and skinnier. So if we were looking at a 5, 12, 13, then what we are saying is we have a right triangle where this is 5, this is 12, and the longest side, the hypotenuse, would be the 13. So that's another Pythagorean triple, and once you have this basic one, you can make as many as you want by multiplying it by a scale factor. So on the first one, it looks like they doubled it, so that's going to be 10. And then the 12 doubled is 24, so the 13 doubled should get you 26. And that's going to satisfy the Pythagorean theorem. So we can say that 5 squared plus 12 squared equals 13 squared. You could also say that 10 squared plus 24 squared equals 26 squared. Those are going to be Pythagorean triples. And then another Pythagorean triple that again is a different shape than the 3, 4, 5. It's a different shape than the 5, 12, 13. Another one is going to be the 8, 15, and this would have to be 17. So in order for this to be true, 8 squared plus 15 squared would need to be 17 squared. So those are your Pythagorean triples. And another thing to be aware of is what they call the converse of the Pythagorean theorem. So the converse kind of goes the other way. The original Pythagorean theorem indicates that you know that you have a right triangle. So if you have a right triangle, then a squared plus b squared equals c squared. Sometimes you might have the 3 side lengths of a triangle and you're not sure if it's a right triangle. So what you can do is test to see if it is a right triangle. So for example, if you had a triangle, and let's say you think it might be a right triangle, but you're not quite sure if this is a right angle. And if you look at the Pythagorean theorem, and if when you work out the formula, if a squared plus b squared is exactly equal to c squared, so they're equal, if this works out to be true, then it must be a right triangle. If when you try to work it out, if a squared plus b squared works out to be greater than the potential hypotenuse squared, then this is essentially telling you that your hypotenuse value, your c value, is a little bit smaller than what it needs to be. So your hypotenuse is working out to be less than what it needs to be exactly equal. So in order for your c to be less, so if c was too short to make a perfect right triangle, then these sides needed to kind of fold in or bend in a little bit in order to make c fit. So that means this angle must be getting smaller. So this is not going to be a right angle right here. This is going to actually be an acute angle. So if a squared plus b squared is bigger than c squared, so that means c squared is basically too small, then it must be acute. So it's not a perfect relationship to make a right angle. It was too short for the c value, so that's acute. And then if it is the other way, if a squared plus b squared is less than the c squared, and sorry, I got interrupted there. So if a squared plus b squared is less than the c squared, then that means c squared is too big. You have too much hypotenuse. So if you have too much c value, then you're not going to have a right angle. You're going to need to have stretched out this c value. So it's kind of like a hinge. So this is going to be too big. It's not going to be a right angle. It's going to be an obtuse angle. So this will work out to be obtuse. So if you're not sure if you have a right angle, you can test it with the Pythagorean theorem. If a squared plus b squared is exactly equal to c squared, then it's exactly a right angle. If your hypotenuse is too small, if it's too short, then it must be acute. And if your hypotenuse is too big, if you have too much hypotenuse for it to be a right angle, then it must be stretched out and it must be obtuse.